So our next lesson will be on enthalpy calculations. So we've worked out whether it's going to be an endothermic or exothermic process, but how do we work out the amount of heat energy that's going to be released or absorbed? Okay, so the learning outcome for today is that by the end of today's lesson you should be able to use stoichiometry to calculate the heats of a reaction for known masses. So let's just review a bit of stoichiometry. Okay, so chemical equations give us information about the chemical involved and the amounts of those chemicals involved. So for example here with sulfur dioxide reacting with oxygen to give sulfur trioxide, this equation tells me that sulfur dioxide is reacting with oxygen to form sulfur trioxide, and that 2 molecules of sulfur dioxide react with 1 molecule of oxygen to give 2 molecules of sulfur trioxide. It also tells me the amount in moles of the reacting of each chemical. So in this case, not only 2 molecules, but 2 moles of sulfur dioxide reacts with 1 mole of oxygen to form 2 moles of sulfur trioxide. Okay, so here's just a quick question to get you thinking again about stoichiometry. If 200 grams of iron oxide is reacted in the above equation, what mass of iron is going to be produced? And the information you require is that the molar mass of iron oxide is 160 grams per mole, and the molar mass of iron is going to be 55.85 grams per mole. So just pause the video now and see if you can work it out. And we'll go and look at the answer very soon. Okay, so welcome back. So hopefully you got the right answer. Let's see if you did. Okay, so here's the answer. So from the equation, you can see that the ratio of iron to iron oxide is 2 to 1. You can calculate the number of moles of iron oxide by simply using the equation number of moles equals the mass over the molar mass, which is 200 divided by 160 and 1.25 moles as from the table. So now we have the number of moles of iron because it's going to be 2 times the number of moles of iron oxide from the equation. Then it's just a matter of simply working out that the mass will equal the molar mass times the number of moles, which is 2.5 times 55.85, giving the answer of 140 grams. So hopefully you got that correct. If not, you should go over your notes and make sure you understand where you went wrong so you don't make the same mistake again. So in terms of thermochemical reactions, these are also balanced equations, but this time we include the change in enthalpy value. So for our previous reaction of sulfur dioxide reacting with oxygen to give sulfur trioxide, the delta H of reaction, or the enthalpy of reaction, is minus 188 kilojoules per mole. So this means that when we have 2 moles of sulfur dioxide reacting with 1 mole of oxygen, 188 kilojoules of energy is released by the reaction. Because it is kilojoules per mole, the amount of energy is related to the number of moles involved in the reaction. Okay, so what happens if you change the amount of reactants? So from the reaction, you can see that when 2 moles of sulfur dioxide reacts with 1 mole of oxygen to give 2 moles of sulfur trioxide, the enthalpy of reaction is going to be minus 188 kilojoules per mole. So that means that if we halve the number of moles of sulfur dioxide, then the energy released will be halved as well, which you can see in the second reaction. So in that case, when sulfur dioxide reacts this time with half a mole of oxygen to give 1 mole of sulfur trioxide, the enthalpy of reaction is this time minus 94 kilojoules per mole, half of what it was previously, because we've reduced the amount of moles by half. Correspondingly, if we double the amount of reactants, then the energy that would be released would double as well. So if you tripled, it would triple, and so forth. So how do we calculate this enthalpy of reaction, or change in enthalpy of reaction, or energy per mole? Well, the equation we use is going to be the change of enthalpy of reaction is going to be the change in energy per mole. Okay. Delta RH is the enthalpy change of reaction. Delta E is going to be energy change in kilojoules, and the number of moles in N. So here's the question. Ethanol burns according to the equation. Ethanol plus 3 oxygens give 2 carbon dioxides plus 3 water, and the change in enthalpy of reaction is minus 1,370 kilojoules per mole. So your job in the next few minutes is to calculate the amount of energy released when 9.2 grams of ethanol is burnt. So pause the video now, have a think about it, get some ideas, and then restart the video and see if you're on the right track. Okay. So the first step is to calculate the number of moles. So the molar mass of ethanol is 46 grams per mole. From our equations we know that number of moles equals the mass over the molar mass. So the number of moles therefore must be, if we substitute the numbers in, 9.2 divided by 46, which gives 0.2 moles of ethanol. The second step is to calculate the change in energy using the formula. The change in enthalpy of reaction equals the change in energy divided by the number of moles. So change in energy equals the change in the enthalpy of reaction times the number of moles. Putting the numbers in, it's going to be minus 1,370 multiplied by 0.2 to give a change in energy of minus 247 kilojoules. So what's that saying is that when you burn this 9.2 grams of ethanol, then you're going to release 247 kilojoules of energy. Okay, second question to see if you've mastered it. So pause the video now, see if you can work it out, and then come back. Okay, so welcome back. So calcium burns an oxygen to produce calcium oxide. The equation for this is the following reaction. 2 calcium plus oxygen gives 2 calcium oxide. And this time the change in enthalpy of reaction is minus 1,270 kilojoules per mole. So calculate the mass of the calcium that must react to release 116 kilojoules of energy. Okay, you think you've got it? Okay. Get ready to see if you're right. So, number of moles equals the change in energy divided by the change in enthalpy of reaction. Therefore, the number of moles will equal minus 116 divided by minus 1,270. Number of moles, therefore, is 0.0913 mole. The mass will equal number of moles times the molar mass, so it will be 0.013 times 40.1 grams per mole to give an answer of 3.66 grams. So hopefully you got that right. If you didn't, go back over your notes and see if you can see where you went wrong. If not, come and see me and I can help you out.